This is Algebra 2 with Trig, 8b.3. This is the first day, so we'll call it 3a. We're just starting to get started with the unit circle. We'll probably have to break this up into two different videos. But the unit circle. The unit circle is theoretically like this here. It's the xy axis. You have your circle that has a radius of 1. But when we look at a unit circle and typically draw it out, we typically draw it so it's much, much larger. But really, where are we looking? Just so we all understand, the unit circle has a radius of 1. It's not very far out. We're really zoomed in on our graph paper when we talk about the circle being much larger. So here we are. We have a circle which is x squared plus y squared with a radius of 1, which has a center at 0, 0 and a radius of 1. That's what we had right here. Now, what we haven't talked much about, we've talked some about radians, we've talked some, of course, about degrees. We haven't talked about the coordinates. And that's where the unit circle really comes into play. There are values along this unit circle that we're going to want to know. What is the unit there? When we talk about it here, and I can zoom in a little bit, we're going to be looking for what is the coordinate at 30 degrees. How far over do you go? It's clearly less than 1, and it's clearly less than 1 on the way up. We're going to need to know that coordinate. And we're going to need to know this coordinate at 45, and we're going to need to know this coordinate at 60. And of course at 90 and all the multiples all the way around. So those are the coordinates that we're looking at. So when we talk about the x-coordinate of each point, get my circle to be a little bit bigger. We'll put a triangle in there. We're going to have theta here. We know the radius is how far? 1. So the radius is 1 everywhere. So this radius is 1. When we talk about this length, how far over we go, and we'll talk about this in detail a little bit later, but we're going to call this an x value. So using which trigonometry function would we use to do the x value over the hypotenuse, or this adjacent value over the hypotenuse? It would be cosine. Using SOHCAHTOA, that would be adjacent over hypotenuse. So we know that cosine of theta equals the adjacent over the hypotenuse. And how would we solve for x in this situation? We would cross multiply. Typically we put our value that's not a fraction into a fraction, and we cross multiply. So this is 1 times the cosine of theta equals 1 times x. So what does x equal? The x-coordinate of each point on the unit circle is the cosine of theta. So now we're going to be able to ask questions like, what is the cosine of 30 degrees? What is the cosine of 45 degrees? What's the cosine of 150 degrees? And that's all based off of our unit circle, and it's the distance horizontally until we get even with that different location. So the y-coordinate, what is that going to be? The y-coordinate is the distance up. So which trig function are we going to use for that? opposite over hypotenuse. So we're thinking about sine of theta equals the opposite over the hypotenuse. Hypotenuse is 1. So we're going to multiply by the 1. So sine of theta is going to equal y in the unit circle. So this coordinate right here is going to be the x, the cosine. The x value is the cosine of the angle, and the y value is the sine of the angle. So the y coordinate of each point on the unit circle is the sine of theta. We haven't gotten into much detail on doing the coordinates. We'll talk about those. Today we're going to mainly focus on the radian and degrees portion, what we've learned more recently. Using this theory, how are we going to do tangent? Coming back to here, what would tangent be? Tangent, we know, is opposite over adjacent, so that's going to be the y value over the x value. So we have y over x, but haven't we defined what y is? Y is sine over cosine. So we'll take our sine value, sine of theta, over our cosine of theta, and that is actually tangent. And you'll use that multiple ways in the future when we talk about trig identities and a whole bunch of others, that we can move them around using what you learned in the past to what we're learning now. But tangent of theta is sine over cosine. So when we speak about learning the unit circle, you need to learn it. What does that even mean? That means you need to know degree values. And you need to know multiples of 30, multiples of 45 degrees. We would typically say 30, 45, 60, but 60 is a multiple of 30. So there's no reason to even say the 30 or the 90 and beyond, because they're multiples of 30. In radian, what's equivalent to 30? How many times does 30 go into 180? Goes in there 6 times. So what's equivalent to 30 degrees in a radian? Would be the pi, which is your 180, it's half of your circle, divided by 6. Pi over 6 is equivalent to 30 degrees because it's a sixth of the pi. It's a sixth of 180. And in the past we've talked about why 180 equals pi. Because the number of radiuses that fit around half a circle is exactly 3.14. We're going to have another multiple special angle, and that's going to be the 45s. How many 45s are there in 180? So the radian at 45 is pi over 4. They're equivalent because 45 goes into 184 times. Pi divided by 4, it makes more sense here that the pi is divided by 4. Okay, you want to be able to evaluate what is the sine at any of these angles. What is the sine at pi over 6? What is the cosine at 45 degrees? What is the tangent at pi over 4? Those are the things that you're going to need to know when we talk about learning the unit circle. Okay, quadrantal angles. An angle in standard position whose terminal side is on an axis. Is on one of the axes, the x-axis or the y-axis. A quadrantal angle is always a multiple of 90 degrees or pi over 2 radian. And we would find all of those locations on a unit circle. So we know that a circle goes all the way to 360. So if we break that into 4 equal amounts on the axes, each of these, we're going to have 90 degrees, we're going to have 180 degrees, 90 more from 180 is 270, and 90 more is 360. So we're just counting our way around. 90 plus 90 plus 90 plus 90. In terms of radian, we know that over here is pi. We've talked about why that is in the past. What is it going to be when we're halfway to that location? It's going to be pi divided by 2. So that's 1 pi over 2. This is 2 pi over 2, which can be reduced down to 1 pi. So what's this one going to be? We have 3 sections. 1 pi over 2, 2 pi over 2, 3 pi over 2. This could be considered 4 pi over 2, but can be reduced to 2 pi. If that's 1 pi, this would be 2 pi. Now we would also need to do our additional locations throughout a unit circle. We're going to flip the page. We'll talk about that. So here is our unit circle. Today we're mainly going to focus on the degrees and the radians of filling out a unit circle. This is very doable. So I'm going to take tracing paper and I'm going to trace out this first angle. All right, this first angle we know is going to start on the x-axis, so we consider that to be 0 degrees. So if we're sitting there, we're at 0 degrees, and then we're going to start to work our way around at different angle amounts, and we're going to talk about their degree values along the path. So the main thing you need to know is what this first one is. It's kind of the one you have to memorize. So by chance, using the previous page, what were we supposed to memorize in terms of angles? What angle is this going to be? It's going to be 30 degrees. So that's 30 degrees. Now watch how I lay my tracing paper over it. I'm going to do an additional 30 degrees, and you see where I land. So that's going to be an additional 30, which is 60 degrees. So the middle one, we'll come back to that. That is going to be 45 completely. And we'll rotate another 30 degrees, and what's it going to be straight up? And that's pretty straightforward because that makes a right angle. And we'll rotate it again. And what would that spot be? That's going to be 30 degrees more, which is 120. Now, you do have to be careful that you skip the one in the middle when you're counting by 30s. So I'm using the tracing paper so you can clearly see that you have to skip that amount. What's this one going to be? 150. And then we'll continue it one more time, and that's going to be 180. So you go ahead and fill out the appropriate multiples of 30 that go on the bottom part of our circle. At home, you can pause the video, and then we'll come back and I'll talk you through it. So 30 more degrees. 18 plus 3 is 21, so this is going to be 210. 30 more degrees is 240. 270 degrees. 300 degrees. 330 degrees. And 360 degrees. And of course, as we've talked about, halfway in between 60 and 30 will be 45. I can come in here with the tracing paper. So you have a visual. This is bigger than 30. It's less than 60. It's exactly halfway in between. It's one of the common multiples that we need to know. We've talked about that as 45. So now we're just going to see what else are multiples of 45. So another 45 takes us right up to 90. So that happens to be the same multiple of 30 and 45 going to the same value, 90. We'll do another 45 degrees, and what angle is that going to be? That is halfway in between here, 15 degrees extra, 45 more than the 90, 135. So we go 45 more degrees, we get our 180, 45 more degrees, and we get our 225, 45 more degrees, 270, 45 more degrees takes us to 315, and 45 more degrees takes us right to 360. So that's how you do the degrees on the unit circle. Should be pretty straightforward. Some people think about it as going by 15s. We're going to skip the actual 15 degrees, so you have to memorize something. You got to skip the 15, but then it's 30 and 15 more and 15 more, and then you have to skip, and you go to 90 and you skip, and you work your way all the way around, and that's another way to have done it. Whatever works for you. The more times you learn it, the more you'll be familiar with just being able to plot out the actual values. Now we're going to talk about radian. So, with radian, I like to talk about chopping our 180 into those equal increments that we had with 30 degrees. So here we have all these equal increments. 1 of them, 2 of them, 3 of them, 4 of them, 5 of them, 6 of them. Okay? So we know that 30 degrees goes into 180 6 times. So how many pieces of pi do we have? If this is considered pi, which we've discussed in the past, because it's the number of radiuses that fit around a half a circle is exactly 3.14. It's the number of radiuses, so this is called a radian. If we stopped right here, how much of those slices would we have taken? We would have taken 1 of the slices. So this is called 1 pi over 6, because we broke pi up into 6 equal increments. Now if we came all the way up to 2 slices, what are we going to have? we're going to have 2 pi over 6, because that's 30 and 30, or pi over 6 and pi over 6, which is 2 pi over 6. So if we have 2 pi over 6, can that be reduced? That becomes pi over 3, or 1 pi over 3. That's really what we want to put there, the reduced radian value. Okay, so we'll just keep going. This is 1 pi over 6. This was 2 pi over 6. So what's this going to be? 3 pi over 6. So if this is 3 pi over 6, can that be reduced? Pi over 2. So here we have 1 pi over 6, 2 pi over 6, 3 pi over 6. So this is going to be 4 pi over 6. And what do we know about 4 and 6? That is 2 pi over 3. Now let's see if that makes sense. We have 60 plus another 60 makes 120. If we have 1/3, or pi over 3, and another pi over 3, which is another 60, another pi over 3, gives us 2 pi over 3. So you can count by thirds, but you got to skip and jump to the appropriate lines to do that. 1/3, 2/3, 3/3. But we typically like to think about it in terms of sixes, because that hits more lines. So this is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So what would be this one? 5 pi over 6. So notice, I'm not memorizing so much. I'm counting my way around it because I understand how it's made. So if that's 5 pi over 6, this one over here could be 6 pi over 6, which of course is reduced just into pi. So you go ahead and fill out the bottom half of your unit circle. At home, you should pause the video, and we'll talk you through the rest. So this is 6 pi over 6. This is 7 pi over 6. This is 8 pi over 6, which can be reduced to 4 pi over 3, because it's another 60 degrees from 3 pi over 3. This would be, that was 8, so this is 9 pi over 6, which can reduce to 3 pi over 2. That's 9. This is 10 pi over 6, which is 5 pi over 3. That's 10 pi, so this is 11 pi over 6. And 12 pi over 6 is actually 2 pi. And we can equivalently do this with 45 degrees. So if 45 goes into 180, how many times? We've got 1 slice, 2 slices, 3 slices, 4 slices. So this is going to be 1 pi over 4, because it was one of the slices of the 4 that make up pi. So this is pi over 4. This would be 1. This would be 2 pi over 4. Well, 2 pi over 4 can be reduced to exactly what we thought before. So several of these start to overlap, and we already have 2 pi over 4. So this is going to be 3 pi over 4. This would be 4 pi over 4, which is reduced down to 1 pi. This would be 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4, which is reduced to 2 pi. This blank here would be 0 pi, because we haven't done any radians at that line. So those are all your degrees and radian for the unit circle. Our next one will talk about the coordinates around the unit circle.